Welcome to an introduction to hypothesis testing. So the idea here is we want to test the validity of some claim about a population parameter. So we want to test the validity of some claim about a population parameter. For example, maybe 30% of California community college students have dependent children. And we want to check the validity of that. We pick a sample, a random sample, that's extremely important, a good sample. So we pick a random sample, find the sample statistic, and then we determine if our sample statistic would be likely if the population parameter were actually, or if our claim were true. So we determine if our sample result is likely or surprising if the claimed population parameter were true. So we've been focusing on the p-hat distribution, so we'll stick with that for now. So some key facts and tools. For the p-hat distribution, the shape, we know that we have that it's normal if he were here, both n times p and n times 1 minus p are 10 or more. In this case, again, n is the sample size. And p is going to be the claimed population parameter, the assumed population parameter. The center, our mu sub p hat, was just p, again, where p is our claimed population parameter. And then our spread, sigma sub p hat, is the square root of p times 1 minus p divided by n. Again, n is sample size, p is the claimed population parameter. The other main thing that we will be using is our normal distribution calculator. So this is in Canvas. We will use that to go from z-score and a shading to probability. So we'll find, this is to find the probability of the or of a sample, a random sample yielding p hat as extreme as ours. So the way we will determine if a result is likely or surprising is basically we'll find the probability of being that result or farther away. So putting it all together, essentially we'll have our p hat distribution. So here's our p hat distribution. Then in the middle is our assumed p. So this is the claimed p. And then we'll find, say, maybe our sample is maybe out here. Then we will be figuring out what is the probability of landing here will tell us if our sample was surprising or to be expected. So this probability tells us if our sample is surprising or to be expected. If the original claim were true. So in order to do this, we'll need to check our shape, center, and spread. We need to know what our original claims were. So, and then we can use or translate through z-score and find probability. So we'll have sort of a series of steps. Once we get to this picture, we'll translate to z-score using z equals essentially our data or our sample of p hat minus the mean divided by the standard deviation. This is in z now. And then from here, we will use the normal distribution calculator to find the probability. All right, so that's just sort of the basis for the hypothesis tests. Once we have the probability, usually if the probability is less than 5%, then we usually deem it to be surprising. So if the probability is less than 0.05 or 5%, then we consider our results to be surprising. So our results would be surprising if the original claim were true. And so this would make us think that the original claim might be false. So then from here, we have strong evidence the original claim was wrong. On the other hand, if the probability is not less than 0.05, or again, 5%, then we have insufficient evidence, or we do not have enough evidence to toss out the original claim. So then we do not have enough evidence to say the original claim was wrong. So in our next video, we will do an example in context.